Hi everyone, this is our AP Statistics video project on planning and conducting experiments. So first of all, what is an experiment? It's different from an observational study, which observes individuals and measures variables without influencing the response. Experiments deliberately impose treatments and try to influence the response. Confounding is when two variables are associated so that the effects on the response variable cannot be distinguished from each other. You want to avoid this because it leads to bad results. However, a common mistake is confusing confounding with bias. Bias is a word you want to use when there's a systematic error in the way you're sampling people, so you use that in an observational study, whereas confounding applies to experiments. So some other vocab words are treatment, the condition applied to the experimental units, and experimental units, the smallest collection of individuals being treated.
So now we're going to talk about ways to minimize the effect of the confounding variable. So the first way to minimize the effect of the confounding variable is to have a placebo. The placebo is a fake treatment given to a control group, such as a sugar pill, as an example, and it helps prevent confounding due to the placebo effect, which is when some patients get better because they think they are supposed to. And so now we move on to blind experiments. This is another way to minimize the effect of the confounding variable. And blind experiments are when the experimental unit is not aware of what treatment they are receiving. So there are two kinds of blind experiments. The first kind is the double-blind experiment, which is when neither the subject nor the person interacting with them and conducting the experiment knows which treatment that the subject is receiving. Another kind of blind experiment is a single-blind experiment, which is when one party knows the treatment of the subject and one does not. So either the subject knows and the experimenter does not, or the experimenter knows and the subject does not know.
Some good techniques you want to have when designing experiments are these four things. Comparison. Compare at least two treatments. Random assignment. Use chance to assign treatments to units. We'll show you how to use a calculator to use a random number generator in a little bit. Control. Keep as many variables as possible the same to avoid confounding. And replication. Have enough units so that the effects of the treatment cannot be said to have been actuated by chance.
So now let's move into an example of a well-designed experiment, and this example can be found on page 243 to 244 of your textbook. So this example talked about a physician's health study, and it tested the effects of two drugs, aspirin and beta-carotene. And they asked two questions. Will beta-carotene prevent cancer, and will aspirin prevent heart attacks? And the subjects of this experiment were 21,996 male physicians. And the treatments were that whether or not they received aspirin, whether or not they received beta-carotene, and on odd number days, the people either received aspirin or a placebo, which is again a sugar pill. And on even number days, they either received beta-carotene or a placebo. And so the entire group was split evenly among each of the four treatment groups. And so again, good techniques for experiment include having comparison, random assignment, control, and replication. So for comparison, they compared both active treatments to a placebo. For random assignment, they used random assignment to determine the treatments of the individuals so that the treatment groups are roughly equivalent initially. And for control, the subjects all had the same gender and the same occupation and also the same schedule for pills. And for replication, they had 5,000 subjects per treatment group, which ensures that the difference in heart attacks was due to the aspirin and also the difference in cancer was due to the beta-carotene and not random variation.
You have 20 subjects and you want to assign half to each of two different treatment groups. To do that, you can use an RNG that we have on our own TI-84. So you go to the math button, all the way over to probability, and option 5 is randint, or random integer generator. So they ask you for a lower and upper bound. Because I said we have 20 subjects, we want to number them from 1 to 20. So the lower bound is 1, upper is 20. And because you want to assign half to each group, first you could generate 10 random numbers, and those first 10 unique numbers would be the subjects that are assigned to treatment group A, let's say. So we want 10 numbers, and you press paste and enter again, and that gives you 10 numbers. So in the case we have a duplicate, like here, you just want to generate one more number through the same process, or keep going until you actually have 10 unique numbers. At the end of an experiment, you want to evaluate its statistical significance of the results, or whether the observed effect is so large that it would rarely occur by chance. We can look at the example on pages 249 and 50 of our textbook, where they ask, is talking on the phone or to a passenger more distracting? To check the significance, we want to ask what would happen just by chance if the 48 are randomly assigned groups many times, assuming the treatment does not affect the results. So in one trial of the experiment here, we have these results. And let's say we're evaluating the number of people in the cell phone group who failed to stop at the rest stop. If we run the simulation 100 times, just assuming that there's an equal chance of them stopping and not stopping for each of the two groups, so let's get 50-50, then only 1 out of the 100 times did 12 or more people in the cell phone group fail to stop at the rest stop. Because this result of 12 or more people failing to stop is unlikely to happen by chance, you see it's only 1 out of 100, so it's 1%, the results of the study should be considered statistically significant.
So now let's move into types of experimental design. So the first kind of experimental design is a completely randomized design, and this is when experimental units are assigned to treatments completely by chance. The next kind of experimental design is a block design. So this is when random assignment is carried out separately in each block or groups of individuals similar in some way except to affect the response. The last kind of experimental design is a matched pairs design, and this is a block design comparing two treatment subjects are ordered in pairs such that two individuals in each pair are similar to each other, and each individual is randomly assigned to one treatment, and the partner gets the other treatment, and then the difference between the individuals' responses are recorded. So during the AP test, make sure that you don't mix up the language of experiments and the language of observational studies. This is a common mistake, so please watch out for it. And this is a list of practice AP problems that you can do. They were on previous AP tests, and they will be helpful in mastering this concept.
Thanks for watching!